Okay, so I found there was some confusion in previous lecture. So I'm trying to go through the previous lecture very fast, right? So as I told you, this is chapter number 3, which I am following word by word of Ziri Black. By the way, you got this book online or no? By the way, Vivek has, by mistake, he has uploaded online. Yeah, I removed it. Okay, we cannot do that, right? It's pirated version, right? So you can find out your own way, or if you want, we can get the Xerox copy. We have one copy in library, right? Okay, so there were few things. All the elements are known as edges, and these nodes are the same as you must have studied vertex, right? Have you studied this, right, in graph theory, right? So it's same as what you have studied in. Have you studied this notation, right? So instead of we are going to call that one as node because that is more suitable for our circuit analysis. But both are synonyms, right? Okay, so this was a simple way to draw a graph for this given circuit. In that case, we are going to take this orientation arbitrary. So in this case, you have 3 nodes. Actually, there are 4 nodes, but 0 voltage node is going to be dropped. So then you are going to have following edges. In your exam, if you are drawing the arrow, please draw only engineering arrows. You know engineering arrows, right? Have you studied in engineering graphics, right? So do not, you can see that I'm trying to draw it, but on paper, on this e-screen, I am not able to draw it properly, right? Do not do this thing. This is not arrow. This is something else, right? Draw only engineering arrows. Okay. And if I am going to write the equation in terms of matrix, which is known as incidence matrix, is going to be as follows. You have to look at the nodes which are actually excluded by 0 volt, and this side you will have all the edges for 1 and at node number 1 you are going to have 1, 4 and 6. 3 edges are visible. Those which are going to have the direction going away, we are going to take it as positive, right? That is what we already agreed, that somewhere I wrote, or maybe. So at this node you are going to have minus I1 plus I4 plus I6 is equal to 0. For node number 2, is there anybody who can help me? Node number 2, minus I4 minus I5 plus I5 minus I2 is equal to 0. Similarly, you can write down the third node, which is going to give you the incidence matrix. Where is it? Right? So for at node 1, there is 1, 4 and 6. So 1, 4 and 6 are going to be filled up with 1. If they are going away, all are positive. If they are coming in, they are negative, right? So that is how it will go. So incidence matrix, no problem. But same incidence matrix which has been written in terms of KCL, you can write down using KVL as well. So if you are writing in terms of voltage form or the KVL, it will as follows. So you need to look at the edges now, not the nodes. So if you are looking at node number, edge number 4, that voltage drop is equal to Vn1 minus Vn2. Similarly, if I want to write down V6 is equal to Vn1 minus Vn3. If I want to write down V5, it's Vn2 minus Vn3. And similarly, you can write down all 6 and you can write down the matrix for all these voltages, right? Any doubt? If doubt, then I can revisit again. I'm going fast because last time we already talked about it, right? Interestingly, if we are observing both the incidence matrix, this is both the matrix are known as incidence matrix. The only difference is one is going to be created by KCL, one is going to be created by voltage. When when it's written in terms of current, it's AI is equal to 0, where A is an incidence matrix and V is written in terms of A raised to T, A transpose times Vn. So these two A's are actually incidence matrix and they are interlinked, right? So that's how you can get the answer, or they have some relation. We already talked about this and we didn't find any difficulty. The problem was when we were looking at cut set and loop set. Actually, we didn't go to loop set, but we went to cut set. So let's look at the cut set one more time. Without going to how to make the cut set rule and other things, before that, we want to write down different equations for the cuts in terms of these currents, because there are two techniques. One is cut set and one is loop set. Cut set is associated with current or KCL. Loop set is associated with voltage and it's using KVL. So there is a graph which is actually, this is equivalent to the circuit which we have started with. So we are making the graph of this circuit and we are making some cuts, right? When you are doing so, we have to make sure that there are following number of nodes 1, 2, 3. If you have 3 numbers of nodes, we are going to, okay, batteries right. So you may have only 3 different cuts. So cuts are equal to the number of nodes. So if there are 3 nodes excluding zero potential, you are going to have 3 cuts. Those 3 cuts are C4, C5 and C6, which is given by this book. So let's assume that right now you don't know how to make the cuts, but by looking at this cut, how to write down the equations. So if you are starting from cut number 4, which is here, right? So when you are drawing such diagram, for this line it is also going this way, and similarly for this line it goes this way, and this line it will go this way. Are you following? Yeah. So if it is in this line, I'll make one more diagram because last time we had some confusion. So cuts will be 3. Let's assume that I am making cut like this. Now I want to find out the direction. This cut, if the number of this cut number is 4, okay, so there was one Anvesh, right? So Anvesh, there was one mistake from my side. These actually are not arbitrary, these cuts, the direction. I'll tell you maybe in next time how it's happening. But if it is this way, then in this circular way everything will be outside. So it's cutting three edges, 5 number, 2 number and 4 number. If this is this side, then all other direction will be outside, right? So then you can write down the equation. If both are in same direction, then it's plus. This is in different direction, this is minus, and it is also other direction, so it's like this. Same thing let's apply here, because at the beginning of the chapter they have given the difficult cut set, I believe. So that's why we didn't get the correct answer last time. So if it is at node number C4, so if it is in this direction, so we can write down following equation. I3 is in same direction of cut 4, so it's plus I3. 2 is in same direction of this cut, so it's plus I2. Yeah, we'll do more examples so that you will have like practice on this. So I4 is also in same direction of this one, and I6 is also same direction. But when we are writing for, let's assume that we are writing for C5. So what C5 is going to do here? So C5 is like this. So if it is going this way on this particular line, this will be like this, this will be like this, this will be like this, and this will be like this. Can you see these red marks which are along the edges, just to make sure that whether they are going in same direction or different direction we are following, because this is going downside, same thing I have done. So I can write down at C5 we are going to have minus I1 minus I2 plus I5 plus I6 is equal to 0. Yeah, okay. The main confusion was this one. So if it is going outside, so I have drawn all the arrows outside the line. So I can write down C6 equal to I3 is in same direction of 6, so plus I3 plus I5 minus I4 plus I1 is equal to 0. So yesterday by some problem, maybe I was making mistake, I don't know, some people got the correct thing, but I was not able to get this minus, right? So now this is correct one, right? Okay.
These direction of cuts, they can be arbitrary, or do they have to
Okay,
be
till now we have not set the rule. There is some way. Okay. Okay. So okay. So on top of uh, incidence matrix which we are writing in terms of KCL or KVL, we are also having extra set of equations which are known as cut set equations, right? These two are KCL and KVL based incidence matrix, right? Okay, so now let's revisiting some of the names. We know what is tree. Do we know? Or tree is the one which is part of the graph, but it will not be closed. If you have graph which looks like this one, so there are two rules you need to remember. It will cover all the nodes. You cannot skip any of the node and you can say that it's a tree, right? So you have to cover all the nodes, like 1 2 3, all the nodes has to be covered, right? Other than that, it should not be closed, it has to be open only. So when I'm saying close and open, that means look, this covers all the nodes, but this is a close image, so close will not be a tree. However, you may have different possibilities. Those possibilities are, right, is it covering all the nodes, right? There might be a possibility that it's also covering every nodes and it's not closed. There might be possibility that you're going from here to here, here to here, and here to here. That's, yes. Similarly, other way also you can find out, and there are many other ways, right? So all those are tree, which follows two rules, which are open and covering all the nodes. None of the node is skipped. When you are drawing the tree, let's assume that I am drawing the tree. So if I'm choosing this as a tree, some other guy can choose another tree also. It's like he can choose n number of trees are available, so um, one can have different possibility of choosing of tree. So if you are choosing this tree, all these edges are renamed as twigs or twigs. Yeah. Other things are known as chords, right? Okay. By the way, there is one more name which I forgot to tell you because this might be useful, which is known as subtree. Sorry, not subtree, chord tree. All the chords are chord trees. Okay. All the chords are chord trees. Okay. Okay. So is there any definition which you are not able to understand? Are you understanding twig, chords, right? Tree, tree, right? Edges, vertex, nodes. Everything we understand. Okay. If you understand all of this, now we are creating the cut set rule. Whenever we want to make a cut set, this cut set rule, let me remind you one more time, it's KCL, it's current based thing. Same thing can be written in terms of voltage. If it is going to be written in voltage, it's going to be actually loop set. In cut set, a cut with respect to given tree edge of a graph is cut through only one twig. In a cut set rule, you can have one twig and n number of chords, right, of the chord tree as necessary to divide the graph into two separate parts, and right. So you are going to have number of nodes is equal to number of cuts. When you are doing this, we should make sure that it will be for a defined tree. Might be like one guy is choosing one tree and one guy is choosing another tree, right? So in the cut set equations you will have different answer, but at the as you are going to get the final answer in terms of transfer function, you will have the same answer, right? So your path might be different, but your answer will be same. So when you are doing this, you should have only and only one twig which is going to be possible. Otherwise, you cannot take any other twig. One more thing on top of this thing, the direction of the cut has to be in same direction of the twig, same direction of twig. This was one modification which I told. Yeah, Anvesh. So it's not arbitrary, it's in same direction of twig. And in a single cut you will have only one twig and others will be a cord or maybe core tree. Okay. So hmm,
The shape can be any
shape of the,
cut.
yeah.
It's not straight line.
So you can have cut set rule says you must have one twig
One twig.
and as many cords you can have, right, in a
If
particular.
I want to cover one twig and all the chords, I can make any
Arbitrary pattern is also possible, is also possible, right? But generally you will understand as this course is progressing, you will understand that how many like cuts are needed and how many edges should be covered, because what you are asking is general question, and this goes to even computer science engineering where people are making so many cuts. They are doing some, have you studied coloring of graph also? So coloring of graph, tagging of particular nodes vertex, right? So you are tagging some instructions, so all these things are happening. So this question is general, that's why I'm not able to answer correctly, I should say, right? But you should cover, as per this definition, you should cover as many number of chords as many you can cover, right? Okay. So if I am using this particular tree, you can see black solid lines are part of tree, 1 2 3 are twigs. What procedure this book is suggesting, that assign orientation to the edges and assign consecutive integers starting from 1 to twigs and continue numbering the chords. What he is saying, if you are choosing this particular graph, then you are going to number 1 2 3 two twigs, and others will have number like 4 5 6. But if another guy who is not using this tree, but if he is using different tree which is like this, then as per suggestion, this is just a suggestion, you can change the number also. So what he is saying, start numbering 1 2 3 for the twigs, as he is suggesting. 1 to like consecutive numbers will be goes to only twigs, and once all the twigs are done, then you will go to other core tree which will have number 4 5 and 6. If you are doing this, it will give you some uniform matrix, and that will be very easy to write down very quickly. That's why he is telling this, and you can make so many cuts. If you have another possibility like this, then you should give 1 2 3 here and 4 5 6 to rest of the them. This will give you some uniform matrix at the end. That's why we are doing this, so that you will have the quick answer. Okay. So as I told you, number of cuts are equal to number of nodes. So there are 3 nodes are available, excluding like 0 voltage. So you are going to have 3 cuts. When you are making the cut, that particular cut will have one twig and more number of chords. This is the only rule. So if I want to make cut for this first twig, which is going to have same name of the twig name, but I am going to call it C1, right? So C for cut, and cut on first twig, which we are going to call it C2. You can see this direction is this side, so this will also this side. So all the direction we are going to check inside, right? As we agree in the past cut. And for this one, are you agree with me now? So the direction of this cuts will be going inside this circle. So that's what I did. This also like that, this also like that. And when we are giving the direction of these cuts, it will be same as the twig. Yes.
Even if there is not a zero node in the graph, then also we need to exclude one of the nodes by counting the number of nodes for number of cuts.
For number of cuts, what's it?
Suppose there is not a zero voltage node, zero voltage,
Mm-hmm.
it is linked to some other circuit. Then also we need to exclude one of the nodes to get the number of cuts.
No. Why? I already told that the number of nodes are equal to uh, the one which does not have 0 volt, right?
Excluding that,
Excluding that.
I'm saying if there is not the zero potential node in the circuit, then also the number of nodes will be total number of nodes minus one.
Okay, that way also you can say it's same. No.
So like if that is not
Number of cuts are 3.
because the rule
Okay.
says
You are saying that if I am going to keep this one, this will be fine. Okay, but I am saying that nodes are excluding the 0 volt.
no, if that zero is not grounded, it is connected to the voltage.
Okay.
Then there will be four nodes. So because
Then there will be 4 nodes, and then
because of what number of cuts are already
yeah, you are right. You are right. Okay. So most of the time in our circuits there are zeros. Okay. You are right. So I agree with your rule. Okay. Okay. But is there any problem in this direction? If somebody wants to revisit this, Gaurav. Okay. So now I am going to write down direct equation. One side you are going to have cuts and edges. So these are the edges, these are the cuts. For C1 cut, can somebody help me in filling up these entries? One is positive, or one will be 1 only, right? This one, 2, 2 is not there. 3, 0, 4, minus 1, 5, 0, 6, minus 1. What about this? Okay, just I am following you what you are saying. Okay. Whatever you will say, I'll write down. I'm not solving this. Huh? 1. Okay. Okay. You can observe here, if you are following this 1, 2, 3 as suggested by the book, you can see that there is a square matrix where you are going to see all the diagonal entries 1, others are 0. So this will be quick. If you are following this numbering 1, 2, 3 to the twig, and on 1 you have cut 1, on number 2 twig you will have cut 2, and on twig 3 you will have third cut, right? Then you will have this uniform matrix. Just you need to take care of this, right? In gate examination also people are asking such questions. Okay, this is straightforward. This matrix we are going to call Q. Q matrix is associated with cut set or KCL. same as what we did, right? Oh, this is another choice. Is it matching the answers, right? Okay. If not, then we can revisit again. Okay.
Sir,
Hmm.
the numbers, the equations can be different for different trees, right?
Different.
Just for the
Yes,
first
yes.
3 cross 3, it will be the identity matrix. Rest can be different.
Different. That is what I told at the beginning itself. You may have different equations, but if you are following this 1, 2, 3, 4, 5, 6, the first matrix will be diagonally 1. That is what you are going to get. Right? You may have another choice, as I told you. You may have another choice. Then again, I am going to rename these 1, 2, 3. Right? So it's fixed that you are going to see this thing, because 1, 2, 3 are twigs, others are chords, so they are not going to interfere in the cutting. If you are following the cut set rule correctly, you will see only this thing. If you are seeing something else, means you made some mistake, right? So what is going to happen in cut 1 for 4, 5, 6? Cut 1 is here.
Um,
You can see here also, right? Those who cannot see. So now 5 and 6 are there,
0 minus 1 is
right? Similarly, can we write down for second cut?
minus 1. Plus 1.
Hmm? Correct, right? Okay.
Sir, for 4
No. Red or they have to go to inside, right? Because they are inside. Minus one, and plus one. Is it okay? What about this one? I'm writing what they are saying. Okay. Okay. Tell me. Okay. Minus one, 0. Right? Second cut. Second was cut was chosen such a way that it will cover one twig and as many number of edges, as many number of chords. I'm following this rule. So one twig and others are chords. Okay. We got this answer. Okay, now we are moving towards loop set. Is there any problem in cut set? Yes. Oh, direction of this. So direction, look, on twig number 1, I am creating first cut, that is C1. It will cover one twig, other chords. So one twig is this one, others are chords. When I am doing this direction will be exactly same direction of first number twig. Then and then you can get all these positive entries, right? When you are doing this is also inside and this is also inside on these different chords. So 6 is also in same direction of twig 1, so it's plus 1. This is in opposite direction of this one, so it's minus 1, right? Okay.
Sir,
Hmm.
the circuit, if you are taking a one switch, there will be possibility of only making one cut.
Sorry, one.
We can make only one cut,
If it is there is only one node,
one twig.
one twig in entire tree.
No, one cut. One cut can only cut one edge.
One twig, other chords. Chord and twigs are also edges, by the way. Chords are also chord is also known as age. Twig is also known as age, but they are special name coming because of their part of
But
tree.
cut cannot, this cut line cannot cut edge chord two times, right?
We already cut.
Twig,
Yes, one twig, only one twig.
right?
Sir, the same chord twice.
Same,
chord
no,
twice.
same chord twice. It's not required. Right?
Misleading.
Yeah, okay.
Sir, let's say for twig two, we cannot make another cut like C2.
Yeah, this is covering mostly all the chords, right? So this is the best way to cut this. One possible cut, right? So one twig, it cannot cut this one. It cannot cut this one, right?
So like in the previous slide, that this
It's same as okay. So you want to go to different design.
yes,
Hmm.
so like for the C2, if we draw straight line, then it can cut two places.
Two places.
Means like triangle type.
You are saying this one.
Yes, like
Hmm. So it's cutting three times in all three.
but this side won't it cut like
Which side?
if we form it a triangle type means reverse
Doesn't matter. Like
yeah like this.
okay, but why to cut same chord again? It's not required. Hmm? One twig and other chords are required. No, no, no. Chords are compulsory. It has to be more than one. And some places, if you are finding that only one twig and all these things, then you don't need cut set. Directly you can write down V equal to IR. Right? Okay. As you are, as I'm seeing lots of curiosity, we'll make some questions for you. Yes. C2 cut. You can include it. You can include it. No, we cannot cut two times. You cannot cut two times. You can do this one. No problem. You can do this one. Hmm? Cuts open loop. Yeah, of course. Why to form circular? Because it will come to another. If I'm doing this, it's cutting 6 and 2 twice. Right? So it is not required. Matrix will change for sure. Matrix will change. It will not a problem. When we'll solve the questions, you will understand. Okay. I'm just creating a foundation right now. We are not solving the questions. Right? Like some like more curious guy can make lots of possibilities. Right? So lots of cuts are possible. Okay. So let's go to the loop set equations. Where are the loop sets? Okay. I should have. Okay. If there is a KVL approach, it will be loop set. When you are doing this, it's a reverse of what you have done in actually in cut set. You are going to create a loop, not cut. You are going to create a loop which is going to have more number of twigs and only one chord, and you have to form a closed loop. Then there is a loop. It's just reverse of what you have done in cut set, right? So do not consider anywhere cuts. Okay. Okay. So when you are doing this, you may form following possibilities. Okay. One more thing. So you are going to have first of all only 3 loops as many number of twigs you have. Number of twigs is going to decide the number of loops here. So there are 3 loops, but 3 loops are going to be made such a way that it's in the same direction of given twig. Okay, if I am making something for twig number 1, it has to be same in twig number if I am making the loop number 1, it has to be in twig number 1 direction. Okay, same as cut set. In cut set, C1 direction was in direction of number 1 twig. Similarly, C2 direction was in direction of twig 2. Similarly for C3. So we are making similar thing. So one possible thing is this one. You see? So it's a complete loop. There is only one chord, but there are so many number of twigs. 2 twigs are available. If I am writing the equation, I am going to have like what I can write down in terms of these. These will be in voltages, by the way. Now not in currents. So what you are going to have? So I should follow this loop. So this is in minus and these two are in positive. Something like this. You see? For this loop, some guy can make another loop which is V2, V3, V5. So for this loop also is possible. Right? You can make another loop V4, V5, V6 also. By the way, all the equations which are written here are not following loop set. This is just for making you make sure that all these are possible loop sets when there is only one chord and more twigs. So we are going to drop those equations which are not following this rule.
So the direction of loop is that of the chord, right?
Right? So here V2, V3, V5, it's fine. These two equations are fine because both have 2 twigs, 1 chord. In this case, V4, V5 and V6, unfortunately, all are chords, so we are not going to use that. Right? V1, V3, V6, V1, V3, V6, that is fine because 2 twigs, 1 chord. In this case, V2, V3, V4, V6, no, right? V2, V3, V4, V5, V6, sorry, V4 and V6. So there are 2 chords, so we are not going to consider this one. Similarly for these two, what you can say? No, right?
5, 6,
Right? So you are going to have only these 3, which are going to have 2 twigs or maybe more number of twigs and 1 chord. Right? So you can write down following equation. When we are doing this, it's happening for particular tree. One guy can have different tree also. So if somebody is taking this tree, the answer will be different, right? As we decided, right? When you are doing this, rename them to 1, 2, 3, rest make 4, 5, 6, so that the matrix which you are going to see, which will be uniform, and last part will be diagonally 1. And when we are writing this equation, this matrix we are going to call it B. Right? All the loop set equations will have matrix B. All cut set equations will have matrix Q. This is generally all competitive exam people are asking with cut set and everything is given. Just you need to write down this matrix. Right? All the fast, all the objective questions, and so you have to take one. It's easy, right? Okay. Okay. Maybe other things we are going to talk maybe next time tomorrow. Yeah. Huh?
Cuts here are irrelevant.
Yeah. Here are it. I copied from the previous image just for making sure that it's going to give the same answer.